So we are doing what we've been doing already, but today we're going to do it with radians. So we're going to calculate coterminal angles, sketch coterminal angles, but using radians. So hopefully it kind of just flows nicely. So let's go ahead and start here. So use black. So if you want to find a bigger coterminal angle in radians, then what you're going to do is you're going to take your original angle and you're going to add to it not 360 but 2 pi. Okay, so whenever you're working in radians, what you're going to do is you're going to be adding 2 pi instead of 360. And if you want to find a smaller coterminal angle, what you would do is you would take your original angle and subtract it by 2 pi. And once again, you could do this as many times as you want. So I'll put n here at the end to represent any multiple of 2 pi. Okay, so let's take a look at a problem here. So this is going to be example 1 here. I'll write down the instructions. Where did my... Oh, here it is. So what we want to do is our directions for example 1 are going to be find a positive and negative coterminal angle. And we're going to start with pi over 6 here. So what kind of makes these things a little bit of a pain in the butt is the fact that you've got to work with fractions here. And answers will always be in the, answers will always be in the form of a fraction instead of decimals. So use that. So if I want to find a positive coterminal angle, I'm going to add 2 pi to that, right? That's a full circle. So what we need then is we need a common denominator. So to do that, I'm going to put this thing over here under 1. And I'm going to multiply the top and the bottom by, 6, so I get that common denominator. So 1 pi over 6 plus 12 pi over 6 is 13 pi over 6. Okay. Now if you wanted to find the negative coterminal angle, we're just going to take our angle and we're going to subtract it by 2 pi. Now we've already found our common denominator, right? Label these, I'll call this the positive one. Go ahead and find the negative one. Okay, so we already found our common denominator. We realize that if we make the bottom of the 2 pi over 6, you end up with 12 pi over 6. And if you subtract those, what you're going to end up with then there would be 1 take away 12 is negative 11 pi over 6. Okay, so there's your positive and negative coterminal angles. Next question, let's do negative 12 pi over 5. All right, so once again, we're going to find a positive coterminal. We're going to add 2 pi to it. We want a common denominator, so I'm going to multiply the top and the bottom by 5. So 5 times the top there is going to end up making the top be 10 pi, right? 5 times 2 is 10. Then we go ahead and add the tops together, negative 12 and positive 10. That makes negative 2 pi over 5. We're still not there, right? That's still not a positive, so we have to do it again. So, but what we can do is we can take that answer and we can call that our negative coterminal angle. You can also get a negative by subtracting 2 pi from that number, and you'll get a really negative number. But this is also coterminal because it's just 2 pi. So we can use that. Let's go ahead and continue this. So if I want to get a positive, I still need to add 2 pi again. So we're going to have 2 pi over 5 plus, now I'm not going to put 2 pi. What am I going to write? No. Huh? We could have done 4 pi at the beginning, but here's what I was thinking. We could put 2 pi here, but if I do that, what am I going to have to do again? We're going to have to get a common denominator, right? But we already did that. So what is the common denominator? 5. And what did we get after we got that common denominator? 10 pi over 5. So, there's no point in doing all that math again. Just take your last one that you got. That's 2 pi, right? Just use it again so you don't got to find 2 pi again. So now negative 2 and 10 makes 8 pi over 5. And there's your positive coterminal. Yeah, so pretty much what's going to happen is sometimes they're going to give you a number that's really negative. And if that's the case, then the first time you add 2 pi, you're just going to get a negative one again. So use that as your negative answer. Sometimes you might have to add 2 pi twice to get there, or 3 times. Or sometimes they'll give you a really big positive number. So if you start with the negative one, you subtract 2 pi once, and you're still not in the negative, so you have to do it again. So basically the point is you need one positive and one negative coterminal angle. And you're just going to be adding and subtracting 2 pi until you get both. So here's 2 problems for you guys to mess around with here. See if you can find some coterminals for those, okay? Okay. So it's gonna help you guys to know at least this much of your unit circle to do this exercise. Okay. So what's this one over here? Yeah. Okay. We can say 0 or 2 pi. You had me there for a second. Now what about from here to here? What's that? Pi over 2. Now what that means is that when we're doing degrees, every one of these quadrants here was 90 degrees, right? When you're doing radians, every quadrant is how much? Pi over 2. Okay? So know that much. If you want to know what is the distance like from here to here, the answer is pi over 2. Okay? Now, what is this one over here? This was pi, right? And that's because the distance from here to all the way over here is pi, right? And so in degrees, that's 180, but in radians, it's pi. So if you need to find a missing quadrant, it's pi over 2. If you need to find a missing half, it's pi, okay? And that's going to be helpful to you guys as we do these next few exercises. So here we go.
So 1 over half and half. No, 1 over 2 and 2. Or 1.
Just one. Just one. And the other one is this, Xanav, actually, so I'm glad you mentioned that. So how much is this? That's pi over 2, right? And how much is this?
That's 2 pi.
That's pi. Half a circle is pi. And then how much is this? 2 pi. So if you guys know those three things, then you'll be good. I forgot about the 2 pi. That matters. Yeah. So when you're doing a unit circle quiz today, you will need to know this. It might be helpful. What was it? It was 3 pi over 2. But for most of the problems we're doing today, just the black, red, and green ones will be the most useful to know. But this could come in handy. If I ask you to find like 3/4 of a circle, then it's 3 pi over 2. Right? Yeah.
So if we go the other way, that's negative?
Yep. Yep. Good questions. Good questions. All right. Let's actually do this problem now then. So the reason we need to know that is because we have to add up angles, right, to find out what this total is over here. Okay, I'm going to bring this over here. So, what is that? That's pi, right? So let's write down pi. And then what is this? Pi over 4. Yep. And that will tell you the total angle we're looking at. Okay, so once again, though, you got to get that common denominator, right? So, what? 4? Oh, yeah. Why did I put 6? You're right, Melanie. Thank you. It's pi over 4, not pi over 6. Why is it pi over 4? They tell you. All right. So we need a common denominator. So what am I going to multiply this fraction by? 4. That's a 1, right? If there's nothing in front of the pi, it's a 1. So what's the final answer there? There you go. So that's what that angle is in radians. Okay? So it's just like degrees, right? You add your way up to it. It's just that we're doing radians, which involves fractions, which involves common denominators. So that's it. Oh, good. Let's do another one. Okay. Just so you guys know, there are, when you're sketching this, there's 1, 2 full circles, and then you go all over here to that. So as you're sketching it, 2 full spirals, and then a loop over to the pi over 3 there. So, here we go. First we have that. What's that? That's 2 pi. Next we have that, which is another 2 pi. And then we have that. What's that? That's pi over 2, right? A quarter of a circle is pi over 2. And then we have this little piece right here, which is pi over 3. So we have 4 pieces we need to add together. The green, pink, brown, and blue. Okay? So, here we go. The green we said was 2 pi. The pink we said was 2 pi. The brown is pi over 2. The blue is pi over 3. So we got to add all that together. Now my advice to you guys is when you're adding fractions, add together anything that already matches well. Like let's say you had two fractions with a denominator of 2. I would put those together before you do anything else, okay? In this case, what can we add together pretty easily? The 2 pi's, right? What does that make? That makes 4 pi. So put together what you can first, and then start worrying about common denominators. So I'm going to put this over 1. What's the common denominator for all 3 of those? 6 is, right? So I'm going to multiply this one here by 6, and this one here by 3, and this one here by 2. And so we end up with 24 pi over 6 plus 3 pi over 6 plus 2 pi over 6. And now we can just add all those numerators together. There you go. So, combine what you can. Find anything that matches. Like anytime you add a whole bunch of fractions together, put all the fractions that already have the same denominator together. That way you have less to worry about at the end. Then get your common denominator, right? All right. No. Not my box. I'll leave that over there for you. You guys go ahead and copy this one down. Okay. So, what's that? Kind of. That's negative pi over 2, right? And then what's this? Kind of. Negative 7 pi over 18, right? Alright, so here we go. So we're going the other way, right? When you go there with a negative. So we have negative pi over 2 for the purple region. And then for the green region, we have negative 7 pi over 18. And our common denominator here would be 18. So I'm going to multiply the top and the bottom of this fraction here by 9, which is negative 9 pi over 18 minus 7 pi over 18, which is negative 16 pi over 18, which can be reduced, and you should reduce. So 16 and 18 can both be divided by 2. So if we do that, you end up with negative 8 pi over 9 as your final answer. So don't forget to reduce if possible. Okay, so first of all, we're going to go from here to maybe, where are we? Okay, from here to here, which is what? And then we're going to go from here to here, which is? And then we're going to go from here to here, negative pi. Right, so we have negative 2 pi, negative 2 pi, negative pi, and then we don't know, right? Negative. You said it too fast, but I think you're probably right. So you guys remember how we found the missing piece before? We subtracted it from 90, right? But we're not subtracting from 90 now. What are we doing? We're subtracting from pi over 2. So here we go. So how to find a missing piece?
We'll go for 7 pi or pi over 2.
Hold on a second. Missing piece. What is your question?
Like we used to put the numbers.
It was 90 minus the piece. Okay. So in this case, it's going to be what? Pi over 2 minus the piece. Say what now? No. No, because right now we're not worried about direction. We're just worried about the size of that piece. We'll put the sign on there at the end. So let's do that. Common denominator here is 18. So I'm going to multiply both by 9. And that's going to give me what? 2 pi over 18, which is pi over 9. So that, now, I shouldn't circle that because that's not our final answer, right? What that is that's my missing piece, pi over 9. So when you have a missing piece, you're going to subtract it from pi over 2. Now, you guys know sometimes you have a missing piece for a half circle, then you subtract it from pi. Or remember when we had degrees, if you had a missing piece from a 180, you would subtract it from 180. So feel free to think your way through those. Morning, sir. But in any event, we're ready to actually go ahead and start calculating these things now. So, make some space for myself here. Thanks, bud. Okay, so what was the red spiral? 2 pi? Oh, thank you, negative 2 pi. What was the yellow spiral? Negative 2 pi. And the purple? Half a circle, right? And then we calculated painstakingly the green region, which we now know is negative pi over 9.
How is it negative?
There, because we're going clockwise. When you go clockwise, it's always negative. And if that's confusing to you, Xana, what you could do is you could just make all these positive if you want to.
Just put negative in the end.
And at the end, just put negative. It's the same thing. But I'm going to just go ahead and stick to this. But yeah, it just basically is the same answer you get. If it was positive, just make sure your final answer is negative. That's all that really matters. All right, so here we go. Let's combine what we can. These three can be combined together. So what's negative 2, negative 2, negative 1? Negative 5. And now we can get our common denominator. So I'm going to put that over 1. Multiply the top and the bottom by 9. And we end up with negative 45 pi over 9 minus pi over 9, which is negative 46. Because they're both negative. So it's negative 46 pi over 9. Right? Because when you have two negatives, right, they combine like normal. And once again, if the negative thing's throwing you, just do it like they're all positive. Just don't forget to make it negative at the end. You would do it the same way as if it were all positive. And I don't think that reduces, but there you guys go. So we learned a couple things along the way here. A quarter circle is pi over 2, a half circle is pi, a full circle is 2 pi. We learned how to find missing pieces here, right? So a couple of things along the way. So I'm going to go ahead and put up some practice problems here for you guys. Let's do 4. What? What? Don't you guys want to practice? It's fun stuff. Alright, there you go. That's for you.